this is, for me, a really, really exciting panel for a number of reasons, which I'm going to get to. But I first really want to thank PTC, the organizers, for putting the program together, and also my longtime friend, Sakamaki-san, who's on the program committee, who really helped create this session, and the PTC group from Japan. You know, the last couple of days, the discussions here about 5G, I think, have been great, because we all have been hearing a lot of hype in the general press about 5G, right? We all hear it's going to be 8K video to your smartphone, full-page ads in papers globally about, you know, 5G is being deployed and so on. But I think there's some real questions about some of those, not the technology, it works, some of those business cases, how fast it's going to be adopted, what are consumers willing to pay. But what's interesting to me is that those are not really, in my mind, the most interesting near-term applications. 5G, in my mind, is going to be incredibly important and is a real game changer. And the discussions here this week have been about those game-changing uses of 5G, not what you read in the general press. And as a result, this has been, for me, the richest, most realistic, least hype discussion of 5G and its potential. And the panel now is going to, I think, drill into some of that, looking specifically at some of the applications related to the industrial applications, how it's going to affect, you know, Professor Murai is going to talk about cities in Japan. And we're going to be exploring sort of these different perspectives. And we have a great panel to do that. You know, the bios are in the program, so I'm not going to go into those. But Seiji Ninomiya from the Ministry of MIC in Japan is going to start us off with just 2 slides. That's going to give us, he's going to present the Japanese vision for the data-driven society and where IoT and what he's going to talk about local 5G fits in. That'll be followed by Patricia Paoletta, who I think you all know from years here is just one of the, you know, policy regulatory experts, and in fact was recently recognized as a best lawyer, which is great. But she's an IoT policy expert, and we can't be thinking about any of this without policy, regulation, and where it fits. And then John Murai, who's, you know, the father of the internet in Japan, is going to talk about some specific applications and uses of IoT 5G as it relates and its deployment in Japan. And then, you know, one of the big issues with both 5G and IoT is security. And we're really lucky to have David Wiltshire here with us from the Department of Homeland Security, and he's going to also be on another session later this afternoon focusing specifically on cybersecurity. But here he's going to talk about cybersecurity and security and the needs for IoT as it relates back to 5G. So let's get started. Seiji.
Thank you, Dr. Pepper. Thank you for your introduction. I would like to start with my understanding of the world we are in. As you know, today is a data-driven society. A lot of IoT devices are connected to the network. Various data accumulated and analyzed as a big data in a cyberspace, and control based on this analysis is fed back to the real world. Through this, the service is well fit to the customer's needs. And social issues such as labor shortage, for example, would also be resolved. As this cycle continues, which is so-called Cyberphysical Systems, that is CPS in short, solution gains more accuracy, that creates a new value. In the wake of such a data-driven society, I think it's 5G infrastructure that enables CPS and improved further. Out of 3 5G features, high speed, multiple terminal connections, and low latency, the ones I would like to focus on are multiple terminal connections for IoT system and low latency for real-time digital twin, so-called dynamic virtual model of the real world. The next comes local 5G.
Want to change the slides,
Next
please?
slide, please.
Next slide. There we go.
It is a 5G mobile communication system where various operators can operate, for example, local government and enterprises, according to their own needs, and flexibly build their own networks using their premises or facilities. In short, local 5G gives us optimized environment that we want. There are a bunch of possibilities for local 5G in the near future, according to their needs. MIC plans to conduct development demonstration next fiscal year. Just as short look at the slide, there are some scenarios like construction sites at factory, in agriculture, and even in disaster prevention. Because of the let's take out the smart factories. Because of the custom-built network, it is tailored to the individual needs, speed-wise and security-wise. Then data is collected from IoT devices in the factory, and production line is going to be controlled based on the digital twin. If we find potential problems, it is possible to stop before real problems occurs. This is just one of the CPS example, but I believe that this CPS is going to be developed to the point where data will be linked across the individual domains as if they were an ecosystem. In any case, the 5G technology is a key enabler for that development. Thank you.
Thank you very much. Patricia.
Thank you, Dr. Pepper, and thank you, Seiji, for laying out some of the great applications that 5G will better support in the IoT space. And first off, I'll address the hype issue, right? The description of this panel is kind of riddled with a little skepticism, and I've had some debates with some of the 5G skeptics the last couple days, and you know who you are. But so first, I'll acknowledge that yes, IoT is already out there. 4G has well-supported IoT, but 5G really will be a better support system for IoT. And the 3GPP, the global standards body that gathers the mobile industry globally together to work on this, they've been working on IoT for many, many releases, back from release 10, and and gradually, incrementally doing more and more in the IoT space with, say, like release 14 came up with connected cellular-based vehicle to everything, V2X, that's a key driving app for IoT. Release 15 had TDD support for IoT. Of course, narrowband IoT had been developed at release 13. Release 15, as you probably know, is the actual 5G release. Release 16, which was frozen in 2018, worked on supporting more density in connected devices. And now we're already seeing deployments of massive IoT, and massive is defined as 1 million devices interconnected, to the internet per kilometer, but maybe with like hyper massive IoT as we are expected in 5G, you could have 20 million, 30 million devices interconnected within a kilometer. But that would take better mesh networking in the technology, better security per individual application, and that's what 16 and release 17 have been working on. Most of the studies actually in release 17 in the current cycle are going to be, to support greater densification in IoT, connectivity. So so yes, there's been a lot of hype. A lot of that's been geopolitical. A lot of it's been commercial, but it is really working out there. And it's not just because 3GPP and the mobile industry and the vendors got together. It's a broader system of trends, right? We see artificial intelligence and machine learning getting a lot of take-up from industry and government, globally because of all its applications. And that really is driving a lot of the IoT development. And in fact, 60%, I think, of the IoT deployed devices today have artificial intelligence or machine learning already in them, and that's only going to increase. And you've got other, macroeconomic trends like the cost of storage decreasing and the cost of CPU and the sensors getting cheaper. So there's a whole ecosystem that's supporting this IoT, and 5G is going to, bring that over the line in terms of that truly massively interconnected IoT deployments. Well, I'll leave it there because we got other folks to hear from, including the father of the internet from Japan.
Thank you.
Okay, yeah, thank you very much. I really agree with you in terms of, kind of a number of devices around, and then probably it should be connected. And so let me introduce some of the, kind of unique approaches from Japan regarding that issue. And you also mentioned about the, kind of data collected from IoT is going to be used for the kind of AI type of application as well, right? And so one of the view we had was that, in Japan, 99+% of residential coverage has been achieved already, right? For LTE, 4G. So it's most of the people and the residents have been, connected with a mobile network already, right? But only 60% of the geographical land has been covered, because that was looking for residential coverage, not for the, geographical coverage. Okay, then what in the other 40%? That's agriculture field and the mountain, forestry, and there are people working in there, and then the devices connected to the internet, which is going to be very important for the IoT context, right? But we are not covering there. So one of the approaches the Japanese government is trying to do is we do have 210,000 traffic signals around the nation, and that is, of course, controlled by Ministry of, Federal Police Department. And then, of course, 5G deployment has been done, and in Japan, the 4 carriers spectrum allocated. And then, they started to work together, and then putting all the ground station in every single traffic light, so that one way from a police department side is that all the signals are going to be connected and to be controlled. And then from the 5G deployment point of view, it is far beyond the residential area to cover. And then what is the additional thing? Then the additional thing is like, all the sensors can be installed on the ground station in the signal. so that it can be used for the kind of automatic driving system and the traffic control and everything. What police going to do, the collecting data is going to be finally to be used. Oh, by the way, today only 30% of traffic signals are connected and controlled. So rest of the 70% should be covered. And then if the 100% covered, then they're going to collect all the data with the kind of traffic control and the congestion, which is contributing to a lot of economies and also the kind of environmental issue as well, right? But they need AI, right, to control. So that's one of the approaches that the different government departments working together and they're utilizing the 5G and then approaching for the both AI, IoT, and also the solution for the coverage.
Thank you. That's really interesting because one of the issues, of course, is real estate, right? It's not high tech. It's where do I place it?
Well, a lot of technical difficulties in front of us, but yes.
Yeah, yeah. Thank you. David. So all these things are going to be out there. Are we okay?
Correct. And they've been leveraged before, so we have to assume that they'll probably be figured out how to be leveraged again. So for us, we recognize as a government that 5G is a game changer. It is basically turning our communication systems the way that we're used to thinking about it, and it's turning it up on its head and kind of starting all over. Where we used to concentrate on security for fiber and copper, now we have to look at radio access networking, we have to look at MIMOs on the towers, how do we make sure that those are secure, that bad things can't happen to those. And then at the same time we have to worry about the supply chain aspect of cybersecurity, making sure that the devices that the users are getting are in fact secure, that they're meeting the standards that they're supposed to meet, and that they're not becoming an issue. Currently, some IoT devices do not get any security updates beyond 18 months, and some IoT devices do not get security updates once you buy it out of the box and put it on the internet the first time. So there's a lot of that needs to be looked at and try to figure out whether we need to make that a regulatory thing or what we need to do with that. So we're really looking at, for security now, instead of the edge of the network, the security now has to pass all the way to the individuals, handheld phones, or the IoT devices, which means we're relying on the users who buy the devices, that they're being good users, they're practicing good cyber hygiene, they're changing their passwords, they're changing their default logins and passwords from what anybody can find on the internet to something that is something that they would only know. And possibly even going beyond two-factor authentication on some of the issues that we'll be using on 5G, just to make sure that we are getting beyond the smart device that's able to allow bad people to get to us through our refrigerator or car or whatever. The other piece that's going to change rather drastically is with the cars driving themselves, the automation, that type of thing. We're also going to have to look at data centers actually moving closer to the users. Instead of having a data center in Akron, Ohio that's processing everything, you're going to end up having data centers that are a lot closer so that the information from the self-driving cars or whatever can get to the data center and figure out what else is around it and get back to the user in time. So all those things are concerns that we have. So again, we're looking at everything from the handset or IoT device all the way back into the network elements, from originating device all the way to the destination device.
Thank you. Yeah, so it's complex, but it's progress. And I agree. I mean, I think we all agree it's a game changer. And my point about the hype piece was getting ahead of itself in terms of what really is going to be the game changer, right? And I think we need to look at it near term, medium term, and then the longer term, and then prepare, particularly on some of these issues related to building in security from the beginning. So I really appreciate the fact that this was a fast, very fast sort of overview. So we actually have time for questions. If not, I have some. And you know, I know that there's going to be another session this afternoon on 5G as well. But are there any questions out there? Okay, if not, I can't see
And while
them.
you're thinking of one, can I just address one point?
Yes, please.
Yeah, the 3GPP security standards, right, are looking at mobile edge computing as well because, right, there will be so much more computing at the edge with IoT devices. So that's certainly the industry is very much aware that they have to address that. But sorry.
Yeah,
Sorry to
no,
take over your
that's okay.
job,
No,
Andre.
thank you for coming back at that. No, that's great. So, Seiji, can you maybe say something about, from your perspective and what we saw, the 5G and how that is going to, are there any plans for 5G for the Olympics? And so I'd like to hear about that.
Well, I think that Olympics, the Paralympics 2020 is a very big event for Japan, and it's going to be a some kind of showcase. What kind of technology of 5G is going to be developed? First, maybe a small size demonstration, but we're going to have the services nationally, maybe. And there are some of the examples of using 5G technologies. For example, in the stadium, there are technology which gives viewers 360 degrees views. From what degrees you would like to see, instantly, very quick. That's one of the applications for the Olympics, but there are a bunch of others.
Yeah. And so one would expect also that there are going to be a lot of people, right, in the stadiums that are going to want to be uploading video, and that this is also one of the things that the 5G network will provide capabilities. And so within stadium, sort of the medium and upper band, right, are going to be different than the lower bands for broader coverage. So it's going to be, I think, really interesting to see how people end up using it within that context. Professor Murai.
Yeah, that's certainly the Olympic, Paralympic coming in the, July, August timeframe. That's certainly the, kind of big opportunity to demonstrate the new technology. Past Olympics, I mean, we've been doing that for a long time, and this one as well. And there's, especially focusing on the 5G and the two major things you should enjoy. So visit Tokyo and then enjoy them. So one thing is that more toward the millimeter band use, I mean 28 gigahertz, and then so people really don't know that what it's going to be used, and then so it's more the spectrum goes straight, and then the bigger opportunity. So as you mentioned, that it's 8K cameras around, and then what kind of a three-dimensional thing can be calculated with edge computing in a closer way. So that kind of a demonstration testing is going on. So that's one of the way to enjoy that. The second one is that the Tokyo metropolitan government decided to dedicate and the release all the 13,000 metropolitan assets, including the big park and the street and the signals again for the 5G ground station installation. So it's going to accelerate the, even the very short period of time from today and the Olympic time, but they're going to, the very rapid installation in the Tokyo metropolitan area for 5G in the public space of the city government, metropolitan government Tokyo, is going to be accelerated. So that I believe that there's, some of the 5G way of enjoying the Paralympics is going to be happening. And also the Paralympic, by the way, then they're gonna work on the very special one for all the handicapped people.
Can I just
And
throw in
last
here?
comment?
We expect great things from, NTT, KDI, Docomo, but there have been 52 5G standardized networks already deployed around the world already in every region, Africa, Latin America, Europe, certainly in Asia. So it's, I'm sure you guys are going to put on a great show.
Yeah, no, and it's coming.
it's already there.
Interesting to see how it's being used. So with that, I'd like to thank the panel for a great discussion.
I really-